Hey everyone, welcome back. This is lesson 4.3, using matrices to transform geometric figures. The objective for today, you're going to be able to use matrices to transform a plane figure. Your vocabulary for today will be translation matrix, reflection matrix, and rotation matrix. You can describe the position, shape, and size of a polygon on a coordinate plane by naming the ordered pairs that define its vertices. All right, the coordinates of A, B, C are A is -2, 1, B is going to be 0, 3, and C is going to be 1, -2. So you can also define triangle ABC by a matrix. So let's look at how they rewrote this. So notice they put the x coordinates on the top of our matrix. We have a -2, a 0, and a 1. And then for the y's, we have our -1, a 3, and a -2. And notice that they pair up with each other. The x and y, -2, -1 stay together. The 0, 3 stays together, and the 1, -2 stays together. A translation matrix is a matrix used to translate coordinates on the coordinate plane. The matrix sum of a pre-image and a translation matrix gives the coordinates of the translated image. So just as a side note, just remember the prefix pre means before. So the pre-image is the original figure before any translations are applied. The image is the resulting figure after the transformation. Okay, example 1 says to translate triangle ABC with the following coordinates. We're going to translate it 3 units left and 4 units up. So I want you to think about what is going to happen when you translate something 3 units left. And what happens when you translate something 4 units up? Well, remember, left and right is going to be our x's, and up and down is going to be our y's. So our translation matrix is going to have a -3 in all entries in row 1 because that's where our x's are, and a +4 in all entries in row 2, which is where our y's are. Here we're going to go ahead and add the two coordinates together. We're going to take our -2 plus our -3, and then we're going to take our 3 plus a -3, 0 plus a -3, it goes over here, and then doing our bottom row, 1 plus 4, 2 plus 4 goes here, and -3 plus 4 goes here. And when we add these up, -2 plus a -3 is -5, 0, the -3, 5, 6, and 1. So now we can see our new image of ABC, and it's written with these little prime marks on here. A prime, B prime, C prime is our new image of our triangle. And the coordinates are going to be A prime is going to be -5, 5. And B prime is going to be 0, 6. And C prime will be our -3, 1. And here it is. If you graph those two out, you can see here was our original -2, 1, 3, 2, and 0, 3. And that one was right here. And now our new image is right here. And you can see our A has moved 1, 2, 3 places left, and 1, 2, 3, 4 places right or up. Our B again has moved 1, 2, 3 places left, and 1, 2, 3, 4 places up. And same with the C. All right, so here's another one to think about. It says translate triangle GHJ with the following coordinates. This time we're going to go 3 units right and 1 unit down. So think about what the new translation matrix is going to look like. And let's take a look at it. So the translation matrix will have 3 in all the entries in row 1 because our 3 is going to be we're going to be adding that to our x's because that does left and right. And then negative 1 is what does our y's, and so we're going to have that in the y section. So here's all of our x coordinates. We're going to add them all by 3, and our y we're going to subtract 1. And let's go ahead and do the math. So 2 plus 3 goes in our first position. 3 plus 3 goes in our second position. 1 plus 3, the third position. Second row, 4 plus a negative 1, 1 plus a negative 1, and negative 1 plus negative 1. So when we add them all up, our new matrix is going to be here. Okay, so G prime, H prime, J prime, the image of G, H, J has these coordinates, 5, 3, 6, 0, and 4, negative 2. And so next we have to draw them on a graph. And so you can see where our original image was. It was here. And when we added 3 to the right, 1, 2, 3, and then 1 down. And that's true for each of our letters. 1, 2, 3, 1 down, and 1, 2, 3, 1 down. So here's our new image. This is our pre-image. And now this is our image with the prime. We'd go ahead and call that our image. And the first one was our pre-image. All right, a dilation. You should be remembering these from a couple of chapters ago when we talked about dilations. A dilation is a transformation that scales, enlarges, or reduces the pre-image, resulting in similar figures. Remember that for similar figures, the shape is the same, but the size may be different. Angles are congruent, and side lengths are proportional. The center of a dilation is the origin. Multiplying the coordinate matrix by a scalar gives the coordinates of the dilated image. In this lesson, so we're lucky, in this lesson, all dilations assume that the origin is the center of the dilation. All right, so let's see what that means. Try an example. It says enlarge ABC with the following coordinates by a factor of 2. So again, let's think about what does that mean? Remember, we've talked about a factor of 2. When we're looking for a factor of 2, when we're going to enlarge something, that means we're going to multiply now. Okay, it says find the coordinates of the vertices of the image and the graph. All right, so here it says we're going to multiply each coordinate by 2 by multiplying each entry by 2. So here we go. Here's our original. Notice this is 2, 3, 2, 3. 1, negative 2, 1, negative 2, and negative 3, 1. There it is. Okay, we're going to multiply the entire matrix by 2. So 2 times 2 right here, 2 times 1 here, 2 times negative 3 here. Now do our bottom row, 2 times 3, 2 times negative 2, and 2 times 1 goes here. All right, when we multiply all that out, 2 times 2 is 4, 2, negative 6, 6, negative 4, and 2. So now remember, our top row is our x coordinates, our bottom row is our y coordinates. So here is our new points for our new vertices. All right, and when we plot them out, you can see that our original image has been enlarged by a factor of 2. So our original image, remember, is called the pre-image, and the new image is labeled with all the primes on it. All right. So A prime, B prime, C prime, the image of ABC has the following coordinates, and you just plot them on there, and there you go. All right, here's another one for you to try. It says enlarge DEF with the following coordinates by a factor of 4 over 3. Find the coordinates of the vertices of the image and graph. All right, so once again, when you see a factor of 4/3, that's going to tell us we're going to multiply everything in our matrices by 4/3. So let's get started. Multiply each coordinate by 4/3 by multiplying each entry by 4/3. So here we go. Here's our original entry, 2, 3. Notice here's our 2, 3, 5, 1, 5, 1, and negative 2, negative 7. Remember, our x's are all the top row and our y's are all the bottom row. All right, so when we multiply by a scalar, remember we just have to multiply the outside number by each entry. So 4/3 times 2, right here, 4/3 times 5, 4/3 times -2. And again, 4/3 times 3, 4/3 times 1, and 4/3 times -7. And when you actually multiply those out, here's what we end up getting. Remember, these are all of our x's, these are all of our y's, and here's our coordinates, our vertices. Okay, this is our x and our y, this is our x and our y, and this is our x and our y. So here we go. This is when you go back and replot these points, and you can see again the pre-image and then the new image. A reflection matrix is a matrix that creates a mirror image by reflecting each vertex over a specified line of symmetry. Let's recall what that looks like. If we have our x and our y and we have a point, let's say this is point 2 and 3. Let's say we have a point right here. If we're reflecting it across the y, our x is going to change from +2 to a -2, but our y stays the same. Okay, so to reflect a figure across the y-axis, you're going to multiply this matrix. It's by the coordinate matrix. All right, and this reverses the x-coordinates. All right, it's going to reverse our x-coordinates and keep our y unchanged. Now take caution, matrix multiplication is not commutative, so be sure to keep the transformation matrix on the left. So what's that saying is we know that 2 times 3 is equal to 3 times 2, all right? But in matrix multiplication, that's not true, so you have to keep it in order, just like when you're doing subtraction, 2 minus 5 is not equal to 5 minus 2. It's the same kind of thing. Let's do an example. Reflect PQR with the coordinates given across the y-axis. So we're going to take our translation matrix, which we talked about just a minute ago, and we're going to multiply. Now let me remind you, when we multiply, you can't just add or something straight across. When we multiply, we take the information in our first row and we're going to multiply it with the information in our first column. Okay, so we're going to say -1 times 2 plus 0 times 2, and that equals -2. All right, so I'm going to do a couple of more just to remind you. We always take the information in our first row, and now we're going to deal with our second column. Okay, so -1 times 2 plus 0 times -1. So notice the 0 is going to keep all of our y's equaling 0. All right, and so that's how we get our -2 here. Again, just do a couple of more just to make sure that we have this down clear. We're going to take our first row and our third column now. All right, and multiplying -1 times 4 plus 0 times 3 is -4. All right, and then we would do the same thing on the bottom. And once we do that, each x-coordinate is multiplied by -1, while each y-coordinate is multiplied by a +1. And when we finally put that all together, we see this image. And remember, this is our pre-image right here, our pre-image, and our new image has got the primes on it. All right. Now, if you want to reflect across the x-axis, we're going to make it look a little bit different, because remember, when we have an x, let's put our 2 and our 3 again. This time we're going to reflect across the x-axis. So our 2 is going to stay 2, but our 3 is going to change to -3. So our x stays the same, and this time our y needs to become negative. So this is going to be where our y becomes negative. All right, and so we're going to use this translation matrix, and our new matrix is going to be with these coordinates in it. Or not our new one, but our originally one that we're going to multiply by. So one more time, when we multiply matrix, we have to take the information in the first row and the information in the first column. 1 times 3 plus 0 times 4, and that keeps our x the same, 3. All right, clearing that out. Again, information in the first row times information in the second column now. All right, 1 times 4 plus 0 times 2 gives us 4. All right, one more time. Information in the first row times information in our third column now. 1 times 1 plus 0 times 2. And that's how we get our 1. All right, and then we would do the same thing to get our y coordinates. Second row, first column, 0 times 3 plus negative 1 times 4 gives us a negative 4. All right, again, second row, second column. All right, 0 times 4 plus negative 1 times 2. Negative 1 times 2, negative 2. All right, and let's go ahead and finish it all out. The last, see, we're going to do our second row, and we're going to talk about our third column now. 0 times 1 plus 1 times negative 2. And that gives us a 2, or negative 1 times 2. All right. So once we get our vertices out and we can plot that, then here we can see our images have been reflected across the x-axis this time. So our pre-image was here. Our pre-image was here, and it's been reflected across the y, or the x. So here's our k's, the same distance from our x. The j, same distance from our x, and our l's are the same distance from our x. A rotation matrix is a matrix used to rotate a figure. Example 4 gives several types of rotation matrices. Example 4 says use each matrix to rotate polygon ABCD with the following coordinates about the origin, and then we need to graph and describe the image. So what we're going to do is we're going to use this rotation matrix right here, and we're going to multiply it by our ordered pairs that we have. 0, 1, here's 0, 1, 2, negative 4, 5, 1, and 2, 3. All right, so there we put our two matrices together, and now we have to multiply. So remember, when we multiply, we take the information in row 1, we're going to multiply and add from the information in column 1. So let's go ahead and put our answers in there. 0 times 0 plus negative 1 times 1 is negative 1. All right, and again, take the information in our first row, and we're going to be multiplying and adding from our second column now. So 0 times 2 plus negative 1 times negative 4, and there we have our next answer. All right, and we follow through on all of those, and we end up with our new image points. Our points are going to be negative 1, 0, negative 1, 0, and then 4, 2, negative 1, 5, and negative 3, 2. All right, our last image, we're going to again multiply, but notice that our signs are a little bit different. All right. Let's talk about this one. So this image is rotated 90 degrees clockwise. Now I can't just tell because I don't have all these matrices memorized, but when we graph it, then we'll be able to see exactly what happened. All right, so we're going to multiply B by our original points again. And once again, just to remind you, we take the information in the first row, and we're going to be multiplying and adding the information in the second row. So 0 times 0 plus 1 times 1. And there we get our 1. All right. And again, it's very long, but you just have to stay very organized and keep track of what you're doing and where you are. Okay, the first row, now we're going to deal with our second column. All right, 0 times 2 plus 1 times -4 is a -4. All right, so once you finish doing all that, you're going to have your new coordinates. And so they are going to be 1, 0, -4, -2. And this is A prime. And actually, we're going to call this A prime prime, and so on. All right, so it says that this image is rotated 90 degrees clockwise this time, and again, unless I see the picture of it, I'm not so clear on which way we went, but that's why we graph it so you can see it. So notice that the first time we rotated 90 degrees counterclockwise, and the second time with the double primes, we rotated our image 90 degrees clockwise. All right, here's another one for you to try. They've given us this matrix to multiply. It's going to be a translation matrix. So let's put it down, and then our points are loaded in: 0, 0, 4, 0, and 0, -3. All right, and we multiply. Remember, you've got to always remember to multiply correctly, which is your rows and your columns. So what's in -1 times 0 plus 0 times 0? Looks like that's going to just be a 0 to start out with. And here's our new points. You have to plot them before you can really see what they're going to be and what happens. So here we go. We can look at this. It moved from to this one and over to this one. So we actually had a 180-degree translation counterclockwise. And that is the end of our math for today. So I hope you enjoyed today's lesson. Keep calm and have fun with math. And I'll see you in class.